Let's talk a little bit about velocity. There are two different types of velocity. We have average velocity and instantaneous velocity. The average velocity is the change in displacement divided by the change in time. Now let's take a minute and talk about the difference between velocity and speed. Velocity is a vector and has direction, and speed does not. So we have to remember that our velocities should always have a direction with them. If we're talking linear motion and we're saying positive and negative, then that's fine. If we have cardinal directions like north and east, then we should include those in our answer. So let's look at this example. If a man runs 1.5 miles north in half an hour and then 3 miles east in 2 hours, what is his average velocity? Now because he travels in two different directions, he has two different velocities. So we're going to look at these in the two separate parts. The average velocity equals change in displacement, and he goes 1.5 miles, divided by the change in time, and it was half an hour. So his average velocity in this time frame was 3 miles per hour, and we can write that, miles over hour, or we can write mph, north. For the second part, when he's traveling east, we can say 3 miles divided by 2 equals 1.5 miles per hour east. And that's how we calculate the average velocity here. Okay, let's talk about instantaneous velocity. And this is the speed at one particular instant. So the speedometer in your car tells you instantaneous velocity. If you're driving on the interstate and you're being very law-abiding and you're driving at 65 miles per hour and you set the cruise control and you drive for 1 hour, then your average speed was 65 miles per hour. And because you set the cruise control, it was also your instantaneous speed at every instant was 65 miles per hour, or should have been. But what if you did that same drive, but you didn't use cruise control? And you tried to stay about 65 miles per hour, but you sped up and you slowed down, and your velocity changed throughout. Even when you turned the wheel, your velocity changed, because velocity includes direction. So while you still might have traveled the same distance in the same amount of time, your instantaneous velocity along the way might have been 63, and then 68, and then 50, and then 69. So it might have changed throughout. The way we calculate instantaneous velocity is the same equation as before, the change in displacement divided by the change in time. The only difference is that we are using the change in time approaching 0. So we want to use the smallest change in time possible, not even a second, a millisecond. In order to do this kind of calculation, we have to use calculus. So for this class, we're going to use average velocity, but when you get to college, depending on the type of physics you take, you might do the calculus in order to solve this.